Now, sometimes in a question, you may be asked to either work out how many sides a given shape has, or what its interior or exterior angles are. Now, to be clear, when we're talking about interior and exterior angles, we're saying if we have like just part of a shape up here in the top right, the interior angle is, surprise, surprise, the angle inside the shape, and the exterior angle is saying if we were to continue the side on, what would be the angle between the outside of the shape and that continuing line? Now, with these kind of questions, for the most part, we have to rely on them being regular shapes. That means that every side is the same length, because that means every angle is going to be the same length. Assuming, therefore, it is a regular shape, we can say that the exterior angle is either 360 divided by n, where n is the number of sides, or, if you already know the interior, you can do 180 minus that, because, as we can see here, that's forming a straight line with the interior and the exterior added together. For the interior, a little more complicated, we can either say it's n minus 2, again where n is the number of sides, times by 180, and then divided by n. Or you can do 180 minus the exterior. Just to explain why the formula looks like this, if for instance we had a pentagon down here which has 5 sides, you can split this up into 3 triangles. Now the sum of the angles inside a triangle is 180, so you have 3 lots of 180, and 5 minus 2 is 3. For any kind of regular shape, you can split it into triangles. The number of triangles is 2 fewer than the number of sides in total. So you'd get all of the angles added up together, being this like 3 lots of the 180, and then the individual angles will then divide by the 5, the number of sides. This is also why if we just want the sum of the interior angles rather than just an individual interior angle, you can just do your n minus 2 times the 180, don't need to divide it by how many sides there are. Or indeed, you could, if you already knew an individual interior angle, you could then times by the number of sides in total. So let's say we wanted to work out the exterior and interior angles of a triangle. Well, a triangle has 3 sides, so for the exterior, we can say that's going to be 360 divided by 3, which will give us 120. And then for the interior, we can just say that's 180 minus 120, which will leave us with 60. If we just wanted to check with the other interior angle formula though, n says 3 because it's 3 sides, 3 minus 2 is 1, 1 times 180 is 180, and then divide that by 3, again, is 60. Okay, but then how about the other way? Let's say instead we know what the interior angle is. We know the interior angle is 135. What then is going to be the number of sides? So we know the interior is 135. The exterior, therefore, is going to be 180 minus 135, which is going to equal 45. Now, if the exterior angle equals 360 divided by the number of sides, if you want to rearrange this to make the number of sides the subject, you can times it up, and then you'll just have to divide the exterior underneath. So in other words, n is going to equal 360 over the e, so 360 over 45, and that will give you that it is an 8-sided shape. It is a regular octagon. Well, if we're happy with that, how about we try an example of your own? What if we had a shape where the interior angle would be 140? What then is your number of sides going to be? So interior, 140. What is the number of sides? If you just want to pause the video to have a go at this yourself, and then you can press play again to check your answer. Alright, so if the interior angle is 140, the exterior is going to be 180 minus this, which is going to give us 40. Then for n, that's going to be 360 divided by 40, which is going to give you an n of 9, making it a regular nonagon. Okay, if we're happy with that, let's move on to an actual exam question. Now here we see a diagram made up of multiple different types of tile, tile A and tile B. Both of them are regular polygons, so they are shapes with the same length sides and same size angles. Work out the number of sides that tile A has. Well, we can't see the entirety of tile A, so we can't just, obviously, hence why we can't say how many sides it has. But we can say how many that B has. B is a triangle, as we can see, so it has 3 sides. Work out the interior angle of that, therefore. You have 360 divided by 3 is 120, and 180 minus 120 is 60. So for B, the interior is 60 degrees. We'll then say if we just look here, we have 3 interior angles making up a full circle. To be clear, as you'll often see, this diagram is not drawn accurately. Yes, it looks like these interior angles are all different sizes, but that's just to stop you from using a protractor. They're meant to be all the same within tile A at each of these points. The angles around a singular point is 360. So if we've used up 60 degrees here within tile B, the remaining lots for the 2A is going to be 360 minus that 60 to give you 300. And here we'll see that's 2 lots of the interior angle of A. So for A, the interior is going to be 300 divided by 2, which gives us 150. Now, if the interior angle is 150, then the exterior is going to be 180 minus that, which will give you an exterior angle of 30. Lastly then, the number of sides of A is going to be 360 divided by the 30, and that's going to give you a grand total of 12 sides for A.